Hi, my name is Gabriel. Welcome to this exam revision session on stochastic interest rate models. Now, before you start doing your revision with me, please read this information written here. It's very important, especially this part highlighted, especially this part which is highlighted. So pause the recording now and read. Then after that, let's get on with our revision. So the first question here is taken from the Institute and Faculty of Actuaries exam paper, April 2017. And without wasting any time, it goes like this. Says, an individual aged exactly 65 intend to retire in 5 years' time and receive an annuity certain. So what we actually having here, we have an individual that is 65 years old that intends to retire in 5 years' time. So he or she will be 70 that time. So the annuity, now this is the important part. Now they are saying the annuity will be payable monthly in advance and will see 20 years, right? The annuity will increase at each anniversary of the commencement of the payment at a rate of 3%. So we have an increasing annuity here, increasing at a constant rate of 3%. Now they're saying the individual would like the initial level annuity to be £20,000 per annum. Okay, it's very important. The price of annuity will be the present value of the payments on the date it commences using the interest rate of 7%. So here, that will be the price of your annuity and it will be payable to the individual. So the individual is going to get 20,000 per annum, increasing by 3% for 20 years. Okay. So the first question here says, calculate the price of the annuity. Now, we need to set out the correct equation for this price of the annuity. Now, I'm going to call that P70. Now, in the first year, we're going to have £20,000 per annum, but that is payable annually in advance, payable monthly. So I'm going to have this, okay? Now, in the second year, this 20,000 is going to increase by 3%. So we're going to have 20,000 into 1,03. But this will be payable for the whole year, right? In advance, payable monthly. Now, you have to be a little bit careful here because what is actually happening, this is the first year, this is the second year, you have to take it back to P70 because this is the second year, so you have to discount it by 1 year. So I'm going to multiply this by V. And I'm going to follow this pattern till year 20. So in year 3, we're going to have 20,000 and we're going to increase this. Now it will be 1,03 to the power 2, payable in advance for a year monthly, but I have to discount it for 2 years. Because if you look at our timeline that we drew, in year 3, this is what is happening. So I'll have to take it back. I have to discount it back for 2 years in order to be at P70. Okay, so I'll do this till year 20. Now, you have to follow the pattern here. Now, if you look very carefully here, in year 1, we had 20,000 and we didn't have the 1,03. So it actually 1 raised to the power 0. In year 2, it was raised to the power 1 and your discount factor was to the power 1. In year 3, it was to the power 2 and your discount factor was to the power 2. So in year 20, we are actually going to have 20,000, 1,03 to the power 19. This will be payable for the whole year, monthly, and you have to discount it back for 19 years. So you have to evaluate this. I'm going to call this equation star. Now I'll be sitting there and say, oh my gosh, how am I going to evaluate this? Well, actually quite easy if you notice the pattern here. Because if you look here, we actually have a geometric progression. And remember, the sum to n terms of the geometric progression is given by A into R to the n over R minus 1. Now your R is your common ratio, and it's given by your second term divided by your first term. So in the actual fact, I'm going to have 20,000 into 1,03, right, V, and I'm going to divide this by 20,000 an annuity payable in advance monthly, right? This will cancel, and this will cancel with this. So our ratio will be 1,03 V. Now, given that we are discounting, the question told you, they did tell you that the rate, they did tell you the interest rate is 7% per annum. So your V is evaluated at 7%. So this will be 1,03 over 1,07. Now our first term here is actually this, because this is the first term of your geometric progression. Now there's no problem here. You just punch this, all your necessary information to the SN formula. Now remember, we are not evaluating SN, but we are evaluating P17. So your A will be this, will be 20,000, an annuity payable in advance, payable monthly, into your common ratio, I've explained, is 1,03 over 1,07. How many terms are here? There are actually 20 terms, minus 1 divided by 1,03 over 1,07 minus 1. And from here, you punch your calculator. There is no problem. Now, you might ask yourself, how do we evaluate this? Well, that's not difficult, because you know that your A, your annuity payable monthly for a year is equal to 1 over 1 minus 1,07 to the power minus 1 over D12. Now, you may use your calculator, but I suggest don't waste time. We have got this in your orange book, so you can take this at 7% in your orange book and evaluate it. And I think I have it here because I didn't want to waste time. It is actually equal to 0.67468. So punching this whole thing, you're going to get the price of your annuity. So you're going to punch this whole thing in your calculator. You're going to get the price of the annuity to be 276,639.72 pence. So that was your price. Not very difficult. You just have to understand that the price we are looking for is when this individual actually retires, which is at 70 years. Then you have to read your question very carefully and proceed as usual. Okay, so this wasn't difficult. Now, the second part of our question says, now, In order to purchase the annuity described in 1, the individual invests £200,000 on his 65th birthday in a particular fund. So what is actually happening here, at 65 years, the individual is going to invest £200,000. So let's continue and see what is happening. So the investment's return on the fund in any given year is now that is extremely important, is independent of returns in all other years, and annual returns are given by the following discrete probability distribution. So we have 4% with 60% probability, 7% with a 40% probability. Now, the question here is asking us to calculate, showing all workings, the expected accumulated of the investments at the time of retirement. Now, at the time of retirement, if you look at our time series very carefully, we'll be at age 70. So we're investing this 200,000 and we want the expected accumulated value at age 70. Now, we've got our random variable here. So they told us that the returns for this 5 years, are given by this discrete probability distribution. So that should ring bells. And they told you that the returns are independent of returns in all other years. So you must recall that, so the formula to that is given by, so now we are answering part 2 of our question. We know that Sn will be our principal amount at age 65, and we're going to accumulate this. They're looking for the accumulated value to the age of 70, so that is 5 years. Now this J, because the interest rate, our interest rate is the random variable, this J is the expected value of our interest rate. So it's the expected value of our interest rate using this discrete probability function. So so in order to find this J, so the expected value of the interest rate in any year will be equal to this J. And you are given your distribution here. So the expected value, you know how to calculate your expected value from your basic actuarial studies, will actually be equal to this 4%. So it is the value times its probability. You are given that 4% has a probability of 60% and 7% has a probability of 40%. Now you punch your calculator here and you're going to get the value of 0.052. So that is your J. So I'm sorry, you're supposed to put your E here to indicate is your expected value. So your expected value of Sn is given by your principal amount, which is £200,000 into 1 plus your expected interest rate is 0.52, all raised to the power 5. You punch this in your calculator because I have it here. I didn't want to waste time. You are going to get, I'm sorry about that, you are going to get the value of 27,696.16. Okay, so that is your part 1. Now you will see later I'm actually going to derive this formula. This is a very important derivation. Now that means you must know this formula. So as you can see here, they just asked it without asking you to derive it. So that means you must remember it. Now, the third part of the question, they're asking you to calculate, showing all workings, the standard deviation of the investment. Now, this is another standard result that you must know how to derive. But in this case, nobody asks you to derive it. They just say, right, you just need to recall it. So this is something you have to know. Now, the formula for your variance of the accumulated value, you recall, is given by, so the variance of S17 is actually equal to your principal amount at age 65 all squared into 1 plus 2j plus j squared plus s squared to the power 5, and you're going to subtract 1 plus j to the power 2 times 5. Now, I'm going to derive these results later, but for now, you are expected to recall it. You should know it. As you can see, you can't waste time deriving these things while the question says calculate. Now from here, it's a matter of substitution. You have your j, but we are missing s, because this is s. I'm sorry, might not be clear. So we are missing s, which s squared, which is your variance of your returns, right? Now, you recall the variance is given by, from your basic actual studies, the expected value of IT squared minus the expected value of IT all squared. So here you are squaring your observed returns times probability. Sum here is just your expected value all squared, which is this. So I'm going to calculate the expected value of IT all squared. So you're calculating here, you're squaring your observed interest rate, and you have to multiply by your probability. So that, I've done it because I didn't want to waste time. So that will be 4%, but I have to square it, multiply by the probability of this, which is, the question told you it's 60%. I have to add there your 7% all squared, and I have to multiply this by our probability, which is 40%. Punching this in your calculator, you're going to get 0.00292. So that is your S squared. From there, it's no big deal. You just substitute all your values into this formula and use your calculator. So your variance of S70 is equal to the principal amount we are investing is £200,000, but we have to square that. 1 plus your j is 0.052 plus your j squared, which is 0.052 all squared, plus your s squared, which is this 0.00292, right? Close that, raise it to the power 5, and subtract 1 plus your j, which is 0.052 to the power 10. Remember here, 2 times 5, which is 10. You punch this in your calculator, which I'm sure you can do that. And you're going to get the variance of S70 to be equal to 6483047.19. Now, you have to read your question. Remember to always ask yourself whether you have answered the question or answer something you would love to answer. The question asks for the standard deviation. Okay, they ask for the standard deviation. You have just calculated the variance. So you know from your basic actuarial studies, in order to get your standard deviation of S70, you have to take the square root. I'm going to call this value star. You have to take the square root of star. So that is not difficult. You're going to take your calculator and punch that, and you're going to get 8051.7374, rounding off to 2 decimal places. And there you have it. Now that wasn't very difficult. You just have to remember the expected value of the accumulated amount and the variance of your so you have to remember the expected value of the accumulated amount formula, and you have to remember the variance of your accumulated amount formula. I'm going to derive those two later in this session. So the last question we have here, where most people make a mistake. Now, here they're asking, now the last part of this question, they're asking us to determine the probability that the individual will have sufficient funds to purchase the annuity. Now, please, we are not given any log normal distribution here or any density, continuous density function. So you can't start using those, but you have to use the discrete probability function given in this question, which is this. You have to use that. Now, we want the probability that our individual has sufficient funds to purchase the annuity. Now remember, the price of the annuity that we want to purchase is this. Now you have to play around with all different combinations here of the returns you are given. You have to play around with I have to go back to my pen. You have to play around with 4%. We have to play around with 7%. We have to play around with 4 and 7% and see which combination will give you an accumulated value greater than this value. Sorry, I just have to see the time of this recording. We are doing great on time, I think. So I'm first going to try 4% and see what will that give me. 4% has a probability of 60% happening. So we're doing part IV. So IV. So I'm investing £200,000 at age 60. I'm going to accumulate this for 5 years at 4%. Remember, don't get confused. 5 years till we purchase our annuity. So I'm going to accumulate this to 5 years, and I'm going to get the value of 24330.5805. Now you can see that's clearly less than our annuity we want to purchase, which is this amount, clearly less than. So we can't take that combination. So that is less than 285,295.68. If we try 7%, 200,000 into 1.07 to the power 5, I'm going to get 2,80510.3461. Now it is greater than our annuity we want to purchase. I'm going to call this P70 so that I won't keep on writing this value. So this is greater than P70, which is what the question asked. Now, okay, before we calculate the probability, let us see other combination. Other combination we have is to use 4% for 4 years and use 7% for the remaining year, and there you're going to get 250,571.35, which is clearly less than P70. So we don't want this combination, we don't want this combination. Another combination is to invest at 7% for 4 years and invest at 4% for the remaining year, and there you're going to get 272,645.5701, which is less than P70. We don't want this combination again because we want our value to be greater than our price of the annuity. Another possible combination we can have is to invest at 7% for 3 years and invest at 4% for 2 years. There you're going to get 265,001.3018, which is less than your P70. We don't want this combination. And the last possible combination you can have is to invest at 7% for 2 years and invest at 4% for 3 years, and there you're going to get 257,571.35, which is less than P70. So this is the only combination we are interested in, that is to invest at 7% for 5 years. Now, what is the probability of this? Now, the question told you 7%, the return of 7% has probability of 40% to occur. So if we invest at 7% for 5 years, do you agree with me that the probability that you are looking for